Let's have the first example. Let's find the limit of x plus 1 as x approaches 2. Here, f of x is equal to x plus 1, and the constant c which x will approach is 2. To evaluate the given limit, we will make use of the table of values and its graph to help us keep track of the effect that the approach of x towards 2 will have on f of x. X may approach 2 in two ways, through values from its left and through values from its right. Remember, the values to be chosen should be very close to 2. Constructing the table of values we have. We will start first with values of x that approaches 2 from the left. Again, you can assign your own values of x as long as you have to make sure that these values are really approaching 2 from the left and that these values are very close to 2. In this case, we will use the following values as values of x. 1.7, 1.9, 1.95, 1.997, and 1.999. On the other hand, we will also assign values of x that approaches 2 from the right. Again, you can assign your own values of x as long as you have to make sure that these values are really approaching 2 from the right and that these values are very close to 2. In this example, we will use the values 2.1, 2.03, 2.009, 2.005, and 2.001. Now, how do we get the value of f of x? All we have to do is to evaluate our function. Our function is x plus 1. When x is 1.7, f of x would be equal to 1.7 plus 1. So when x is 1.7, f of x is 2.7. Similarly, 1.9, when x is 1.9, f of x is 2.9. When x is 1.95, f of x is 2.95. When x is 1.997, f of x is 2.997. And when x is 1.999, f of x is also 2.999. Now, looking at the values of f of x, we can see that as the values of x approaches 2 from the left, our values of f of x are also approaching 3. Meaning to say, the limit of x plus 1 as x approaches 2 from the left is equal to 3. Again, the limit of x plus 1 as x approaches 2 from the left, take note that the negative exponent there denotes that this limit is a left-hand limit. The limit of x plus 1 as x approaches 2 from the left is 3. Completing the table, when x is 2.1, f of x is 3.1. When x is 2.03, f of x is 3.03. When x is 2.005, f of x is 3.005. And when x is 2.001, f of x is 3.001. We can also say that as x approaches 2 from the right, the values of f of x are also approaching 3. This case, we can say that the limit of x plus 1 as x approaches 2 from the right, take note that we use positive exponent, is equal to 3. Meaning to say, the limit of x plus 1 as x approaches 2 is equal to 3. Hence, the limit of the function as x approaches 2 is 3. In symbols, we write it as the limit of x plus 1 as x approaches 2 is equal to 3. Now let's find the limit using the graph of the function. Here we have the graph of f of x is equal to x plus 1. Now, we are going to find the limit of x plus 1 as x approaches 2. First, we will have to locate where is x equals 2. So that is x equals 2. Now, we can see that as x approaches 2 from the left, f of x is equal to 3. Similarly, as x approaches 2 from the right, f of x is equal to 3. Therefore, the limit of x plus 1 as x approaches 2 is 3. Let's have example 2. Investigate the limit of the function x squared plus 1 as x approaches negative 1. In symbols, the limit of x squared plus 1 as x approaches negative 1. Now let's have first a table of values. Since x is approaching negative 1, we have to make sure that our values are really approaching negative 1 and are very close to negative 1 from both sides. Let's have first the values of x as x approaches negative 1 from the left. For this example, we will use the values negative 1.05, negative 1.04, negative 1.03, negative 1.02, negative 1.01 as values of x that approaches negative 1 from the left. On the other side, we will have the values of x as x approaches negative 1 from the right. We will use the values negative 0.95, negative 0.96, negative 0.97, negative 0.98, negative 0.99. Now, how do we find the values of f of x? By simply evaluating the function. When x is negative 1.05, f of x is 2.10. When x is negative 1.04, f of x is 2.08. When x is negative 1.03, f of x is 2.06. When x is negative 1.02, f of x is 2.04. When x is negative 1.01, f of x is equal to 2.02. Now we can see that as x approaches negative 1 from the left, f of x also approaches 2. So we can say that the left-hand limit of x squared plus 1 as x approaches negative 1 from the left is 2. Now let's look at the right-hand limit. When x is equal to negative 0.95, f of x is equal to 1.9. When x is equal to negative 0.96, f of x is 1.92. When x is equal to 0.97, f of x is 1.94. When x is equal to negative 0.98, f of x is 1.96. And when x is equal to negative 0.99, f of x is equal to 1.98. Now we can also see that as x approaches negative 1 from the right, the values of f of x also approaches 2. Therefore, the right-hand limit of our function as x approaches negative 1 is 2. Now let's look at the graph. This is the graph of x squared plus 1. Now, we will try to locate where is x equals negative 1. So x is negative 1 is there. Now, examining our graph, As x approaches -1, f of x is equal to 2. As x approaches -1 from the left, f of x is equal to -2. And as x approaches -1 from the right, f of x is also equal to 2. Therefore, the limit of x squared plus 1 as x approaches -1 is 2. Now let's have the third example. Investigate the limit of f of x equals x squared minus 4x plus 3 all over x minus 3 as x approaches 3. In symbols, we have the limit of x squared minus 4x plus 3 all over x minus 3 as x approaches 3. Constructing the table of values, we assign values to x. We have to make sure that the values of x are really close to 3. Now from the left, we have the values 2.7, 2.08, 2.9, 2.99, 2.999. And from the right, we have 3.3, 3.2, 3.1, 3.01, 3.001. Okay, how do we get the value of f of x? By simply evaluating our function. When x is equal to 2.7, f of x is equal to 1.7. When x is equal to 2.8, f of x is 1.8. When x is equal to 2.99, f of x is equal to 1.99. And when x is equal to 2.999, f of x is equal to 1.999. On the same manner, x is equal to 3.3, f of x is 2.3. When x is equal to 3.1, f of x is 2.1. When x is equal to 3.01, f of x is equal to 2.01. When x is equal to 3.001, f of x is equal to 2.001. Now we can see that as x approaches 3 from the left, the values of f of x also approaches 2. On the right side, we can also see that as x approaches 3 from the right, f of x is also approaching 2. So we can say that the limit of x squared minus 4x plus 3 all over x minus 3 as x approaches 3 from the left is equal to 2. And the limit of x squared minus 4x plus 3 all over x minus 3 as x approaches 3 from the right is equal to 2. However, when we evaluate the function when x is equal to 3, we will get 0 over 0. And 0 over 0 is indeterminate. Now remember that any number over 0 is undefined, and 0 over 0 is indeterminate. Now since when we evaluate the function when x equals 3, it will give us an indeterminate. In this case, what is the limit of the function? Now let's try to look at the graph of x squared minus 4x plus 3 all over x minus 3. Now examining the graph of our rational function, we can see that there is a hole at x equals 3. That explains why when x is equal to 3, f of x is indeterminate. Now, we are looking for the limit of our function. Since the limit of the function as x approaches 3 from the left is equal to 2, and the limit of the function as x approaches 3 from the right is still equal to 2, the limit of x squared minus 4x plus 3 all over x minus 3 as x approaches 3 is 2. Meaning to say, when your left hand limit and your right hand limits are equal, then that is the limit of the function. Now let's have this example. Investigate the limit of the radical function f of x is equal to the square root of x minus 2 as x approaches 2 from both sides. So we have the left and the right side. Now, evaluating the limit of f of x equals the square root of x minus 2 as x approaches 2, we can see that from the left, the values of x are less than 2, so the limit does not exist. When the limit does not exist, we will use D and E, because the square root of x minus 2, when x is less than 2, is not a real number, since x is less than 2. However, when we evaluate the limit of f of x as x approaches 2 from the right, we can see that our limit exists. So when x is equal to 2.2, f of x is 0.447. When x is equal to 2.01, f of x is equal to 0.1. When x is equal to 2.001, f of x is equal to 0.032. And when x is equal to 2.0001, f of x is equal to 0.01. We can see that as x approaches 2 from the right, the values of f of x are also approaching 0. Meaning, the limit of the square root of x minus 2 as x approaches 2 from the right is equal to 0. Now, since the limit of the square root of x minus 2 as x approaches 2 from the left does not exist, and the limit of the square root of x minus 2 as x approaches 2 from the right is 0, take note that our left-hand limits and right-hand limits are not equal because the left-hand limit does not exist, meaning to say the limit of the square root of x minus 2 as x approaches 2 does not exist.